In this video, you'll learn the command line and why it's essential to computer and IT professionals. You'll also learn how to open the command line on Windows, Mac, and Linux. You'll learn the different parts of the command prompt, gain a basic understanding of the computer's file system, the essential commands every programmer needs for navigating the file system, and how to view and interpret file access permissions.
Hello, I'm Jeffrey Sessoms. Welcome to Lesson 1 of my Command Line course. If at any time you want to skip to a specific point in the video, then be sure to use the links in the description below. Also, I'm putting together a PDF of all the commands that are covered in the course. When it's done, I'll put a link in the description as well, so be sure to look out for that. Let's get to it. So what is the command line and why is it useful? In the early days of computers, one of the earliest operating systems was called Unix. Unix allowed multiple users to connect to very large and expensive mainframe computers remotely to share its computing power and resources. Users would log into the mainframe remotely using a terminal that mostly consisted of just a keyboard and a screen. Initially, terminals didn't use a mouse or graphical user interface like we're used to today. The keyboard allowed multiple users to send instructions to the computer, and the screen would provide a textual interface to view the input sent to and the output received from the computer. Over the years, many instructions have been written to reduce what used to be a complicated series of tasks into a single word or command. Many commands accept inputs or arguments that modify the behavior and can even be combined with other commands on a single line to produce very powerful results, such as securely copying files across a network to a server. In short, the command line is a text-based user interface that allows the user to enter commands to the computer from the keyboard without the need of a mouse. It also might be helpful to know that people often refer to the command line as the shell, terminal, console, prompt, or as the command line interface. Nowadays, most people interact with computers using a mouse, a touch screen, beautiful high-def color screens, or their voices instead of using the command line. But don't be fooled. For a programmer, the command line is a very powerful tool. From the command line, users can navigate the file system, view and edit files, manage user accounts and permissions, work on remote computer systems like web servers, write scripts to automate tasks like backing up and restoring files, process files to generate reports, and even build and deploy web applications. Now that you've heard what the command line is and why it's useful, let's learn how to use it to navigate the file system. Generally, each operating system implements their own version of the command line. For this course, you'll need a computer running a Linux or Mac operating system since they provide the command line by default. Windows comes with its own text-based user interface called the command prompt that uses different commands that'll be covered in a later course. So if you're on a computer running Windows, then check out my 5-minute video, How to Install Linux on Windows, that demonstrates a quick and simple way to install Linux virtual machine on Windows using Windows Subsystem for Linux. To get started, open your system's command line interface. If you're on a Mac operating system, then press the Command and Spacebar keys simultaneously to open the Spotlight search box, and enter Terminal to open the Terminal app. If you're running a Linux operating system, most Linux systems use the keyboard shortcut Ctrl-Alt-D to open the Terminal app. Otherwise, search the file system using the keywords terminal, command, prompt, or shell to launch the app. If you're running Windows and you installed Linux using my guide, How to Install Linux on Windows, then enter Ubuntu in the Windows search box to launch the command line interface. When you launch the command line interface, you'll be greeted with a prompt. The prompt tells you that the computer is ready to accept commands. Its appearance may vary depending on which system you're using, but on Ubuntu, you can see that the prompt includes some useful information. It displays the user that I'm currently logged on as, followed by the host that I'm on. It uses the colon as a separator. Then it displays our current working directory, the tilde. The working directory represents your position in the file system and is the default location where operations occur unless you indicate otherwise. The tilde is a symbolic reference for our user's home directory. Following the working directory is the $sign, which marks the end of the prompt itself. The blinking cursor shows the position where keyboard input will be entered on the command line. The print working directory command displays the absolute path to the current working directory. The absolute path is the complete path from the root of the computer's file system to a resource. The first / here represents the root directory and is the very beginning of the computer's file system. Home is the name of a directory found at the root of the file system. / are used to separate directories on the command line, and Jeffrey is the name of my current position in the file system, also called my working directory or home directory. In other words, I'm currently working in my user directory, Jeffrey, found in the home directory, which is located at the root of the computer's file system. So the print working directory command is useful to determine your location in the file system relative to the root directory and the other directories along the path. The list command displays the contents within a directory and by default ignores hidden files. Here within the directory, we have several more directories: documents, ebooks, images, and projects. A hidden file is a file name beginning with a period, and we'll see an example of a hidden file in just a moment. First, let's take a look at command arguments. In the intro, I mentioned that many commands accept arguments that are used to modify a command's behavior. Let's pass the name of a directory in our working directory as an argument to the list command and see what happens. In this case, I'll pass the documents directory to the list command. Here in the documents directory, you'll see several text files and another directory called messages. Now, you may have noticed that Ubuntu adds some helpful coloration to distinguish between file types. Don't worry if your system doesn't offer that feature, because later we'll see that the list command offers us a way to see the file types as well. Let's pass the name of a directory that is outside of the working directory as an argument. But before we do that, let's review where things are. Remember that our current position in the file system, otherwise known as our working directory, is within the directory Jeffrey, here. Within that directory are the directories documents, ebooks, images, and projects. We listed the contents of documents, which contains several text files, and the directory called messages. Well, what happens when we pass the messages directory, which is outside of our working directory, to the list command? Notice that instead of listing the contents of messages, the list command returned an error message along with some helpful information. The error message displays the command where the error occurred, here, followed by the value that caused the error, messages, and several short descriptions of the cause. Cannot access messages. No such file or directory. In this case, the cause of the error is that, like other commands,
The list command looks in the working directory for the messages directory, and when it cannot find it, list produces an error message. That's because messages is found in the documents directory, here, and not within our working directory, here. So to list the contents of the messages directory, we need to specify where it can be found by passing either the relative or absolute paths to the list command. Let's look at an example of that. The relative path is a partial path to a resource on the computer's file system from the working directory. Let's pass the relative path to messages as an argument to the list command. Notice that the slash symbol between documents and messages is used to access a child directory. In this case, documents is the parent directory of messages since it contains the messages directory, while messages is the child directory since it's located inside the documents directory. Also notice that the contents of messages was displayed correctly. That's because we specified to the list command where it can be found relative to the working directory. The absolute path can also be used to achieve the same result. To determine the absolute path to messages, we can use the result of the print working directory command that we used earlier, which is right up here. Then we can append the relative path to messages that we used just a moment ago here. As you can see, we get the same result as we did before when we used the relative path. Of course, entering the absolute path can be very wordy. That's why relative paths are so useful. By now, the screen may be a bit crowded, so let's learn a new command that we can use to clear the screen. And that command is simply clear. Remember that the list command ignores hidden files by default. So far, we've only glimpsed at the contents of the working directory. To see the entire view, let's pass another argument called an option. Options are also called flags and are prefixed with a hyphen and often passed to commands to change their behavior. To see the hidden contents of a directory, use option A with the list command. Both files and directories are hidden using a period followed by a name. Here we can see the /rc hidden file, the profile hidden file, and some others. Landscape's actually a hidden directory, but we'll learn another way we can tell the difference between the hidden files and hidden directories in just a moment. To see the hidden contents of another directory inside the working directory, we can pass both option A and the directory name to the list command. For example, if we wanted to see the entire contents of ebooks, we could enter ls-a ebooks. And here you can see the entire contents of ebooks displayed correctly. Notice there's a period without a name following it, and another 2 periods without a name following it. In fact, you may have noticed this earlier when we used the list command with option A. These 2 items here are actually symbolic references to the file itself, represented with 1 period, and the parent directory, represented with 2 periods. These symbolic references are actually found in every directory in the file system, and they can be used to specify relative paths to other resources. The print working directory command shows that we're currently in the directory Jeffrey. To display the contents of the parent directory, home, without having to pass the entire path, we can simply enter ls-a and use the symbolic reference. ... Here you can see the contents of the home directory. It has a symbolic reference to itself, a symbolic reference to its parent directory, which is actually the root directory, and it also has the directory Jeffrey. To see the entire contents of the home directory's parent, which happens to be root, we can pass its double period reference to the list command. Now remember that whenever we use more than one directory on the command line, we need to separate it with a /. So ls will use ... to access the parent directory of our current directory, which is home, / and then we'll use the symbolic reference found in home, right here, to access the root directory. And here you can see the entire contents of the root directory displayed correctly. Let's go ahead and clear our screen. The last list option that we'll look at is option L, which stands for long format. It displays the details of the directory's contents in an easy-to-read format, and is one of the most useful options. Notice again here that the hidden files are ignored by default. To see the details of the hidden files as well, we can combine the option A and option L with the list command. Here we can see that option L displays each of the item's access permissions, number of hard links, the owner of the file, as well as its group, the size of the file in bytes, the date it was last modified, and the file name. We'll cover the details more thoroughly in a bit. We can also combine multiple options with the directory name to display the details of its entire contents. Let's see what's available in our working directory again. To see the details of the entire contents of projects, we can enter ls-al projects. Here we see the entire contents of projects displayed. You can even pass files to the list command to examine file details individually. Let's display the details of just the chatbot Python file you see there on the screen. Since the file isn't in our working directory, we'll need to pass a relative path to it. So let's enter ls-l projects chatbot . Here we see the details of just the chatbot file. I know that so far we've used the list command so much that many of you are probably anxious to see more interesting commands, but I have good reasons. First, this simple command illustrates how almost all other commands work. Now you know that commands have options, many accept file names, directories, and paths, and those arguments can be combined in many ways. You also have a good idea of a computer's file system structure and how to look around for things. Going forward, it's important to remember these concepts so that you can use them with other commands. Let's clear the screen and finish the list command off by examining the details displayed by the option L. To make the things a little bit more interesting, we'll also list the hidden files. Once again, option L of the list command displays details of the contents of a directory. Starting on the left and moving right, we'll begin with the first character, which is the item's file type. A dash tells us that the item is an ordinary file, while if we look just below, the letter D indicates that the item is a directory. You'll see either of these letters most of the time, but occasionally you might see another letter, such as the letter B for a block device, C for a character device, P for a FIFO or named pipe, or the letter L for symbolic link. After the file type, these 9 characters describe the file access permissions for the owner, group, and other. The first 3 characters here describe the owner's access. The next group of 3 describe the group's access. And the last 3 describes other access, or everyone else's access to the file. So let's take a look at the first group of 3. R means read permission, W means write permission, and X means execute permission. In other words, the owner has the ability to read, write, and execute to this directory called Documents. That owner is actually Jeffrey. Looking at the next group of 3, we see that the group, which also happens to be Jeffrey, also has read, write, and execute permissions for this directory. And the last group of 3 has the same file access permissions for this Documents directory. Now, if we look above at this file, you'll notice that there are dashes in place of where we see other characters here. Looking at the first group of 3, we see that the owner, Jeffrey, has read and write permissions to this file, but not execute permissions. So the dash actually represents a missing or lack of file access permission. And we can see here for the group Jeffrey, the group Jeffrey only has read access, and the same for everyone else. Now, for most of us, the access control list or ACL flag will not be visible unless ACLs are enabled on your system. So if they are, then a plus sign right here means that ACLs are enabled and the file has an ACL associated to it. Access control lists are a topic outside of the scope of a command line course, so we'll save that topic for later. The next character here displays the number of hard links to the file. Again, it's not necessary to discuss hard links to use the command line, so we'll move on. Next is the owner, like we said before. Then we have the group. Next is the size of the file in bytes. So we have a 0 here. What does that mean? Well, it just means that this file isn't quite a byte, so it's 0 bytes. Next, we have the last modified timestamp. And lastly, we have the file name itself. So far, all we have done with the print working directory command and the list command is look around the file system. Let's clear the screen and learn a new command that allows us to actually move around the file system. The change directory command changes the working directory. Another way to view it is that it changes your location in the file system. The change directory command alone sets the working directory to the user's home. Since we're already within the home directory, nothing changes. So let's see that behavior later when we're not in the home directory. To change to a specific directory within the working directory, pass the directory name to the change directory command. Let's use the ls command to see what's available within our current directory. Okay, let's say we have some work to do in projects. To move there, we can enter cd projects. Notice that the prompt displays the working directory as ~projects. We can use the print working directory command also to verify our location in the file system. As you can see here, the absolute path shows that we are in the directory projects. Now, we don't have to move up or down the computer's file system one level at a time. Typically, we use the / as a separator for directories on the command line, but the / alone is a symbolic reference to the root of the file system. So we can use it to change our working directory there by entering cd /. Again, notice that the prompt updated to display our working directory as the root. To display the contents of the working directory, we can use the list command once again. Since the change directory command's default behavior sets the working directory to the user's home, we can use it to return home by entering cd. As you can see, the prompt displays our working directory as our home, or in this case, it's showing the symbolic reference to our user's home directory. Let's clear our screen. As I mentioned before, we can pass relative and absolute paths to commands. So if we know the path to the directory we want to go, then we can pass the path to the change directory command. Let's see what's in the directory again by entering ls on the command line. Now let's look into the projects directory by entering ls-al projects. That way we can see the entire contents. Okay, let's say I have some work to do in the account manager directory. To work on my account manager project, I can use the absolute path to set my working directory there. I think I know this from memory, so I'll enter cd /home /Jeffrey /projects /account manager. Notice my prompt updated to my current working directory, which is good. Also notice how wordy using the absolute path can become the further into the file system you are. It's easy to enter a typo that causes an error whenever you use the absolute path like that. That's why using relative paths are so useful, because they can reduce the number of errors that are entered on the command line and saving you some precious time. Okay, let's say that later on I decide to edit a document in my documents folder, my home directory. Well, then I can pass the relative path to the change directory command. But before I do, let's think about this for a moment. I'm currently in my account manager directory. I can use the symbolic reference for the parent directory, which is ... which will take me to the projects directory. And within that directory, I also know that there's a symbolic reference to its parent, which would take me to the home directory, where we find documents. Okay, I think I got it. So let's enter cd ... takes me to projects / ... takes me to my user's home directory, and then / documents takes me to my documents directory, where I can edit my documents. All right, we're good. All right, that wraps up lesson 1 of my command line course. In this video, you learned the command line and why it's essential for computer and IT professionals, how to open the command line on Windows, Mac, and Linux. You also learned the different parts of the command prompt, a basic understanding of the computer's file system, how to view and interpret file access permissions, and you also learned the essential commands that every programmer needs for navigating the file system. Be sure to look out for lesson 2 of my command line course, where you'll learn the essential commands every programmer and IT professional needs for manipulating the file system. Also remember that I'm creating a PDF of all the commands that I cover in the course. When it's finished, I'll place a link to it in the description. If you're serious about improving your knowledge and skills as a developer, then make sure to click the subscribe button and turn on notifications so that you can get more courses like this in the future. Thanks for watching.